Here's the second video. We are going to be doing question number 2. First, let's go ahead and look into the GeoGebra software. And you notice that this tool here is to create a polygon. We're going to create a triangle. We don't need a regular triangle, which would be equilateral. We're just going to do random triangle. You need 3 points. So we're going to go 1, 2, 3, and a polygon is a closed figure, so go back to the original point to close it. Here's our triangle. Notice that it gives you some information, the length of each side, but it does not give you the measure of each interior angle. To do that, what we're going to do is we're going to use our measuring tool. So we're going to measure an angle, and to measure the angle, say I want to measure angle B, I start with this point A, go towards B, and then towards C. So I'm going to do that right now. And it names it alpha. We're good, and we've got 94.4 degrees. Now I'm going to measure my angle C, which it's calling beta. And now I'm going to measure angle A, which it's calling gamma. Now let's say you don't want those labels for those particular angles. You can right click and we can rename it, and instead of alpha, let's call this beta. And notice that if you have more than one beta, it's going to give a subscript for the subsequent betas. But let's go ahead and rename this angle. Right click, rename. And instead of beta 1, we're going to rename this gamma. Usually use gamma with C, beta with B, and alpha with A. And we're going to rename this one now. And this one we're going to rename alpha, which is right here. So we've got our 3 angles, and notice you can't see this angle here. Well, all you have to do is select your move tool, and we can move this over here, and we can move this here, just like so. Move inside the figure, outside the figure, wherever you'd like. So now we've got our angles labeled with the measurements. And the next thing that we're going to do is we're going to do a calculation. So for my input here, I'm going to do the sum of those 3 interior angles of my triangle. Alpha plus beta plus gamma. And notice that it gives me 180 degrees. Well, to check the interior angle sum of a triangle, what we can do is we can move the angles, and it doesn't matter what you do with these 3 points, the interior angles will always add up to 180 degrees. Now let's go ahead and make our triangle a little bit smaller here so we've got room to work. I'm going to move it over here in the corner. There we go. Okay, the next thing we're going to do is we're going to make a quadrilateral and measure its interior angles. So the next thing we're going to do is select our polygon tool, and for a quadrilateral you're going to need 4 points. Excuse me. Here's our quadrilateral. We've got our 4 points, and now we need to measure the interior angles, and it's going to be done in the same way as we did the triangle. And I'm just going in alphabetical order to keep things consistent. And there we go, got them all labeled. Let's make this so that we can see it pretty easily. There we go. Okay, now the next thing we're going to do is we're going to create a regular pentagon. Now you don't select the polygon, you select the regular polygon to do this. This is going to make all the sides exactly the same size. So our regular pentagon, we're going to start here. And we've got, oh, I messed up again. Like I said, if you ever mess up, you can always fix it by clicking the undo button. Now, let's try again. So, regular polygon, here we go. There are not 4 vertices. There's supposed to be 5 vertices because this is a pentagon. So there we go. Here is our regular polygon. And you notice that it's still doing the same sort of thing. That's because when I'm trying to move that polygon, I need to switch this over to the move tool. So now I can move it where I want. Excuse me. So notice that the points are changing whenever I move it, but the sides are not changing. It's because it's a regular polygon. We set the sides, and if I want to increase the sides, it increases all of them because it's a regular pentagon, hexagon, quadrilateral tool. So now what we're going to do is we're going to measure all of these interior angles, same way that you did the triangle. Let's try that again. That's not measuring the interior angle. Let's try this one here. There we go. And let's do this one here. Now, it is a regular polygon, so all the interior angles should be exactly the same. And in fact, they are. They're all 108 degrees. So we've got the triangle, quadrilateral, regular pentagon, and we've found the sum of these interior angles for the triangle. Now, to prove by induction that the sum of the interior angles of an n-gon is n minus 2 times 180, what we're going to do is we're going to create 2 triangles out of my quadrilateral and then apply what we know to be true to the new situation. So I'm going to go over here to polygon. I'm just going to re-click these 3 points here. And there is my new triangle. I have 2 triangles making up my quadrilateral. Now, I know for a fact that one of these triangles has a sum of 180 degrees, and this other one also has a sum of 180 degrees. But if you want to check, you can. You would just do the same thing what we did before, the interior angle measurements, and then go ahead and add them together to see if they are 180 degrees. So for induction, we know that this sum is 180 degrees and this sum is 180 degrees, and because these angles are adjacent to each other, it means they share a side. That means that the total sum of the angles inside of a quadrilateral should be 180 times 1, 2. So let's go ahead and double check. Let's see, what were those original angles called? We had this one plus this one plus this one plus this one. and we get 360 degrees. And of course, you know 180 plus 180 is also 360 degrees. Now, what about the next portion? What about this regular pentagon here? How can I divide this? Well, I could use a quadrilateral, which would be the previous step, or I could divide it into triangles. So what I'm going to do is, I know now with my induction proof that the sum of the interior angles of this quadrilateral, any quadrilateral, will be 360 degrees. Let's go ahead and select our move tool here. And as you can see, the 360 down here, it's not changing. If I move this angle, everything else is changing, but the sum is not changing. So I'm going to use this information here and apply it to here. So I'm going to create a polygon out of this portion of my regular pentagon. Now, this is my quadrilateral. I know that the sum of its interior angles is 360 degrees. Now, I also know that this is a triangle, and its interior angle sum is 180 degrees. Notice that these two angles here are adjacent, and their sum is going to be this 108 degrees, which is the pentagon's interior angle. Same thing over here. So what I'm going to do is I'm going to take my 360 degrees and then add 180 degrees to that. Now let's say you don't want to do that in your head. Let's take 360 and we're going to add 180. And it does the math for you if you don't feel like doing the math in your head. Now, let's take all of these angles here. They're all 108 degrees. So let's take 108 and multiply that times my 5 interior angles. That is also 540 degrees. So by induction, we have proved that n minus 2 times 180 is the sum of the interior angles of an n-gon. Notice that for n sides, in this case 5 sides, subtract 2, you get 3, multiply times 180, you get the 540. Here you have a quadrilateral, 4 sides minus 2 is 2 times 180 equals 360 degrees. Here it is here. And n minus 2 for a triangle is 3 minus 2, which is 1, times 180 degrees is 180 degrees. And that's true for our base case, which was way up here. Now, if you want to look at the formal proof, there's a tool that you can use. It's a media tool here. Also in regular GeoGebra, it would be under the slider here, where you can add an image. I'm going to go ahead and add one, and I've already saved it as a file. Now, this is my formal proof. Let's move this out of the way. Nope. There you go. So the formal induction proof of an n-gon interior angle sum. Here it is, right here. And we went over that in class. Thank you for listening.